Thank you all very much for being here today on this beautiful, at least here in Kansas City, fall day. What we'll be talking about today, if you can't tell, is multi-cloud applications. Now, before we get into that, just kind of a bit about me if you don't know. I've been developing software for longer than I care to admit to. Most of it, honestly, has been on-prem in the security and the perimeter of a data center. And now working to move software up to the cloud, making it cloud native for hospital system in New York City. I should also add an energy company here in the Midwest. And we're definitely seeing a lot of momentum at Keyhole towards moving things to the cloud in general. So that was one of the catalysts for this particular presentation. So you know that my bias is, I am a pragmatist. I would rather get something done than get nothing done. Good, don't let that be the enemy of perfection. I guess I should get that tattooed on myself at some point. I'm not here to sell you a SaaS service or a device. I'm here to tell you these are the things that I have seen. These are the things that work really well. And these are some of the things that you might want to avoid, for lack of a better term. And the recommendations too are not geared towards typical enterprise architecture like CTOs. There's many other presentations you can go to that could touch on that kind of information. The stuff that I'm going to be talking about today is really from an application development standpoint. As AppDev developers, as architects, even managers of software development teams, what are the things that you need to be thinking about when you're deciding on moving an application up to not just only one cloud, but having it span many of them? So to level set, to kind of describe where we're at, for the longest time, almost all of us, unless you're a recent graduate, have had some experience developing and deploying applications within a data center. A company will buy some sort of large building. They'll make sure that there's badges and there's key cards, that it's climate controlled. The degree of disaster recovery is suspect on some of those things. But, for the most part, we deployed software on-prem. We were always sure that it was behind a firewall. That was always very important. So there were some, shortcuts, so to speak, that you could take. There are also differences in terms of, how you deploy software. Do you do it through Jenkins? Do you do through TeamCity? Do you just copy and paste it onto a server? Hopefully not. Don't feel bad if you do. If you do, Keyhole Software is here to help you make sure that you don't do that anymore. But, it's something that we've all seen at one time or another. Now, if you think about that as the Stone Age, we didn't go immediately from some caveman making a wheel all the way up to a Tesla. There's different degrees, different elaborations, different improvements that we made along the way. And some of the constraints that we have, especially in terms of once you want to go to the cloud, there's just so many vendors to choose from. How do you know which ones are right? And much less, how do you want to make sure that you have software deployed on all of them simultaneously so that your application can run there? How do you allow for application development teams to make innovative products while keeping them secure? And how do you ensure that you can automate as much as you can your deployment pipeline? So like I said, there's some assumptions that we've always been able to make when we've been deploying software on-prem. We have these virtual machines that are always on. The amount of nines that we could rely upon was crazy. We didn't have to worry about network latency so much because everything was in a data center, or at least extremely co-located in a data center. We didn't have to worry about Mr. Robot breaking into our data center and putting a USB drive in, because there were always these physical safeguards. So maybe we could deploy files to a server that had passwords in them, but they weren't protected. These are all just very rational assumptions that we can make. We also, in terms of costs, could assume that we buy a VM and it's good for 5 years. That's a typical hardware refresh life cycles. Then after 5 years, you got to buy new bare metal, but it's a one-time cost, and you only had to worry about it maybe once every 5 years. Maybe you amortize it over the course of 5 years, but it's a relatively fixed cost. And When you got a VM provisioned for you, you manage it yourself. You get to remote into it. You get to install software on it. Sure, there might be some safeguards in place, but it was your VM to do with as you wish. Going from on-prem to just getting an application into one of the clouds, that in itself is a mind shift. For instance, I never want to provision another virtual machine for the rest of my life. Like, if I could get away with never having to do that again, I would be happy, just because it's a pain. There's just so many things that you have to consider when you're creating one of these virtual machines to deploy your code up to, that it's better, the ROI is there, to instead have some vendor paid to do this stuff, and all you do is make use of their platform as a service offerings. Whether it be Kubernetes deploying a pod onto there, whether it be an Azure App Service deploying a Docker image on there. It's better to rely upon a vendor that has done these things professionally than an application dev team to do it. Because the app dev teams, we're really good at understanding users. We understand how to take problems and find software solutions to them. We're not experts in VMware. That's not our niche. Any application development team, that's not their niche. So it's better to pay a cloud vendor to do what they do well, and so we can focus on what we do well. We're also much more of guests than owners. When you get these resources in the cloud, they're yours for as long as you pay them. So just like going over to your in-laws' house, it's nice, they'll cook for you, they'll clean for you to a certain extent, but you don't live there permanently, and that's okay. You just have to understand that it's their house, they're paying the mortgage, you're there as a guest. So you might want to tidy up after yourself, you might want to keep your room clean. Whereas on-prem, you get a VM, it's yours. You can party, you can rent it out as an Airbnb, so to speak, if you want to. Like, it's yours. And the other thing about being on-prem is that you have really, really good networks. The people that are in enterprise networking are super sharp. They understand how all the switches, all the routers, how all the internet traffic goes back and forth, intranet. When you're in the cloud, that's not so much of a given. There can be regional outages to internet service providers. There can be connectivity blips that make your application appear to go offline for some users and not others. So how do you even design for the fact that you're going to have an application where you might have to show a loading screen, whereas on-prem, something that would take, 15 milliseconds might take a second when you're up in the cloud. And much less that, it's in coming up with this presentation, looking at all the different offerings that the major cloud providers offered, they all offer some things that are slightly the same and some things that are slightly different. So if you want to select one cloud vendor to be on, you're gonna have to understand their idiosyncrasies. It's like moving to a foreign country. You don't really understand the lay of the land until you've actually lived there and been there for a month and gone through a major holiday. All of them are unique. All of them do something different in their own particular way. So the cloud is where everyone is moving. Probably about 5, 6, 7, 8 years ago, we really started at Keyhole seeing a push toward getting things on the cloud, on the cloud, on the cloud. And now we're seeing an interesting push of being like, well, we want to take advantage of multiple different clouds. Now, it's a caveat. When I say multiple different clouds, I'm talking really about the major three: AWS, Azure, and GCP. There are many other clouds. There's, IBM's Bluemix, Oracle's OracleX. I don't remember what theirs is named. There's a ton of them. But in terms of just pure market share, these three are at the top. AWS, without a doubt, they were sort of the grandfather of like the cloud PaaS revolution. When I checked last, they had about a third of the market share, which is, it's pretty good. And, we have a lot of clients on AWS. Azure, I think, is an up and comer. They, even with Microsoft, I think right now, the most profitable company in the world, they have tons and tons and tons of integrations that they offer. We've seen an enormous amount of businesses during COVID-19 move to Microsoft Teams as their collaboration platform of choice instead of Slack. And they offer ubiquitous communication, first-class features of all these different things in their ecosystem that allow you to talk to each other. And when you're deploying applications onto Azure, it feels very native to have data move back and forth and use all these service offerings. And rounding out, number 3 is the scrappiest of the bunch, GCP. They are only at a 10% market share, but they are very, very aggressive in going from number 3 to number 2. They are putting out a crazy amount of offerings every week, probably even more, honestly, than AWS. And they're very motivated to go from the third string quarterback, so to speak, up to the second string quarterback. And they will do whatever it takes. So AWS, it has a ton of offerings. And when I looked, I think it was over, it was hundreds. So I think it was around like 200 or so different individual resources that you can create an application out of. They are, they were the initial one, they're the biggest one, and they have a lot of API support. I mean, it goes back to when Jeff Bezos commanded that all connectivity between different applications within Amazon had to be through APIs. They couldn't do any of file dumps, they couldn't do anything fancy, it had to be API to API. And they expanded upon that much more when they got to AWS. So you can do almost everything you want to through APIs. And it is a very good general purpose cloud vendor. Azure, on the other hand, is a bit more focused on the Microsoft existing ecosystem, like Azure Active Directory, Office 365. They are very good at offering sort of low barrier, low code, no code options for building applications, things like logic apps or even function apps. But they're also not your grandpa's Microsoft either. They're doing a bunch of support in terms of Docker, in terms of Linux, in terms of Kubernetes, where they're trying to expand their ecosystem as much as they can. GCP, by far, is my favorite vendor for large amounts of data. Google search is sort of the quintessential example of a massive amount of data. I mean, they've indexed trillions of pages, and they took the knowledge that they learned from building Google search and applied it to being a cloud vendor. So you can take advantage of BigQuery, which is the same stuff that powers like your Google searches, have that fed into from an eventing system, their pub sub, and you could do things at scale that it's really hard to get on the other cloud vendors. So of all these 3, they all have their own sort of advantages and not necessarily disadvantages, but maybe things they don't do as well as each other. They all have similar limitations. So networking is probably the biggest limitation that I have. When you think about how you have applications on the cloud, you have your user interface, you have your middleware, and then you have your database. Let's say you had a database on all 3 of those cloud vendors. How do you keep the data synchronized between all of them? Not so easy to do. I mean, you could do it on-prem if you have a couple different VMs with the same database, but how do you know that your 50th and your 95th percentile, for instance, of your network traffic is going to fit within what your users need it to? It's so variable, the connectivity between one vendor and another. I know even between like my house and Netflix, sometimes the connectivity goes up and goes down. Now, granted, I'm on a personal internet line, I'm not on a dedicated business line, but the same problem exists. Traffic from one physical location to another physical location, it's determined by physics. It's the speed of light at the very best. And we as humans, we've come up with some ways to kind of get around that. But at the end of the day, it's a non-trivial consideration that you need to take if you're going to have an application on all those 3 vendors. And SLAs are also an important thing to understand too. So at least on Azure, that's the one that I'm most familiar with. Their service level agreement is what's called 5 nines, which roughly equates to 5 minutes of downtime per year. Well, that doesn't mean that on January 1st, right at midnight, it's going to be down for 5 minutes, and then for the rest of the year, it'll be completely up. Those 5 minutes can happen anytime in the year. So how do you, as an application developer, try to figure out different ways of making your application perform where you might have areas where just the connectivity goes online, goes offline. Multiply that by how many clouds you're on, how many services you're using. It's really hard to be able to plan appropriately for that and to even understand how you're going to do that unless you start it from the very beginning. So it's much easier, I would say, to have an application that is sort of built from day one, understanding I'm going to be on all these clouds. If you're trying to retrofit an existing legacy application where it was developed on-prem with all the assumptions, good and bad, of on-prem, it's really hard. It's not impossible. Don't get me wrong. It can be done. It's just you really have to understand why you're doing it. And that leads me to one of the things that I love to talk about are motivation. Why are we even doing this? Every business has its own use case for wanting to develop software. They have some problem that they're trying to solve. And we as application developers and architects have to get in their heads. We have to understand not only how are we going to solve this from a technical side, but what is the actual problem that we're trying to solve? And for instance, if you needed to develop an application to go out into, I don't know, the Death Valley, for instance, and measure temperature. Well, if your application requires 100% internet connectivity, that's not a great assumption to make in Death Valley. There's probably very poor cell service there, to be very generous about it. So you really have to understand what it is that you're doing and why you're doing it. And that will sometimes lead you down, if you're talking about a multi-cloud, the path of the lowest common denominator. So if you think about NoSQL offerings, they all got them. I mean, there's no shortage of NoSQL offerings. Cosmos DB, DynamoDB, Cloud Data Store, like you can do NoSQL on any of them. You can do Kubernetes on any of these clusters. You can do CI/CD on any of them. But why are you doing it? What is the advantage of having an application run on multiple clouds versus just one? One reason that we commonly hear is high availability. You know, we want, even if, you know, God forbid there was a hurricane that hit the East Coast, and that's where a lot of Microsoft's data centers in that region are, you know, maybe in like North Virginia, well, we still want our application to run. It's like, well, that's good. What about your data? Are you going to have East Coast people's data specifically reside on the East Coast, West Coast people reside in maybe California? It's unlikely, I mean, it's possible, but it's unlikely that we would have both a hurricane and what's it in the Pacific? A typhoon. A typhoon hit simultaneously, and then in the Midwest, you know, maybe we have a couple F5 tornadoes, you know. I mean, I'm sure, I'm not a meteorologist by trade. Like, I'm sure it's possible to have that, but it's very, very unlikely. So what scenario, you have to understand, are you really designing for? I could see the advantage of having multiple cloud providers, but almost every cloud provider offers you multiple regions. You know, Azure has, I think, 7 or 8 in the United States, and data locality can also matter too, because for some regulations, you can only store data within a certain geographic proximity. So, you know, it's theoretically possible to use one cloud vendor and have it move the data around and manage it for you. As soon as you introduce a new cloud provider, it's not impossible, but it gets much more difficult because there's so much setup that it takes to get any of these things working just on one cloud vendor that if you try to do multiple, you really have to be disciplined and principled about what you're doing. You can't do it manually. Well, you could do it manually, but you'll end up not enjoying your life very much if you try to do all of this stuff manually. And there are tools that help make life much easier if you're going to try to have just not only a single cloud, but a multi-cloud setup. To where infrastructure as code, or you'll sometimes see it referred to as infrastructure as configuration, it allows you to describe what you want done. So if I was doing something on GCP, I would say, create a BigQuery data store, create a BigQuery table, create a BigQuery view, and then that, instead of being, maybe PowerShell scripts or CLI scripts, it would be like blocks of not code, but more configuration saying, hey, this is what I want done. And then a tool like Terraform or others would essentially do the thing that you want. There are a couple different offerings in this field. There's Terraform, and then there's tools that aren't Terraform. And as a general rule for me, when I run into, well, you could choose this, or you could choose everything else that says they're going to be this thing in a couple of years, just choose the thing. So, I mean, if you're going to be in the cloud, Terraform is probably what 85% of teams choose. You might as well use it. It is ubiquitous in terms of its usage, but it's not like it's a one-size-fits-all tool. The same concepts and configuration that might work on AWS won't necessarily translate verbatim over to GCP. There's different configurations that you have to do for all these different types of resources. There's different types of resources in general that you might be able to compose to get the same things done. But it's not like being at the Olympics and being able to speak French, like there's just different languages and there's different ways of doing things. Every event at the Olympics is slightly different. Much in the same way, every cloud vendor, if they're a track and field event, to use the analogy, they're doing something where they're either running or throwing stuff, but they're all slightly different. So you can get away with using a tool like Terraform because it gives you sort of a lingua franca, but you have to understand creating an app service or even creating a Azure Kubernetes service on Azure, it's going to be slightly different when you do an AWS Kubernetes or you do a GCP Kubernetes. That's not to say you shouldn't do it. It's just you have to understand that it's slightly different. One of the interesting things that we've seen is there are different vendors that are trying to create their own multi-cloud tools. So it's kind of weird. Like Microsoft is making a tool called Azure Arc that lets you manage AWS and GCP from within their confines. It kind of makes sense, honestly, from a business perspective. You want to keep people in your ecosystem. You want them to be reliant on you to have that vendor lock-in so that they can keep your business. And even if you want to use some features that are on some other clouds, that's fine. You're using their tools to do it. So, it's not a bad idea. It's just sort of an interesting one. Some other things to think about, especially for me, because I work in healthcare, is HIPAA. Everyone, assuming you're all in the United States, you have a right to make sure that your medical records are protected. And even if where you're receiving services from, they have to make sure that your data resides within the United States. So there might be some startups over in other countries that might be able to provide some information, provide some good services, but the data has to reside within the continental United States. And you actually have the ability, as part of the Cures Act, to request your medical records, and hospitals have to comply. Now, if you think about an application that spans multiple clouds, that's going to be something you really have to plan for. How do you extract data from 4 different cloud vendors to give a patient their medical records? You're just a custodian, maybe at best, of their data, but it's their data at the end of the day. So how do you have plans in place? How do you have considerations so that you know that, hey, if this happens one day, you'll have to give them the information? How do you make sure that people can only deploy resources within a specific set of regions so that the data doesn't accidentally leak out? And then there are other conflicting regulations like GDPR, where if you're a resident of the UK or the EU, you have the ability to request someone delete your data. Now, if you're on-prem, that's a little bit easier. You control the servers, you know which ones they are. In a cloud environment, we typically, in most applications that I've worked on, we try our hardest to make sure that people can't delete data. We might deactivate things. We might replace, supplement things with like newer versions. But deleting data, that's just not what we do in an enterprise. But under GDPR, you're required to be able to allow that. And then we're actually getting something like that in the United States soon. It's House Resolution 8152. So you will have the ability to request that your data actually be deleted under certain scenarios. So if you think about how many different places you have to replicate the data to in a multi-cloud environment, if you haven't appropriately prepared for that, it's going to be not a very enjoyable week or two or month to actually be able to support that if this is something that does eventually happen and you get a request for. And kind of taking a step back to what I talked about earlier, there are all these different offerings that each cloud vendor has, things they do well, things that they don't do well. You might want to be able to move your code from one vendor to another. Maybe they change the terms of service or the contract, or maybe something just doesn't go right and you want to go from one to another, but you don't want to be locked in. One of the ways to prevent against that is to use something, what Jamie presented on a few months ago, is the Serverless Framework, to where you are writing code in such a way that you take a request, you give it back a response, you try to do the minimum amount of code and configuration to get the job done. And by doing that, you make something that's very portable, where you can go from one to another to another. That prevents you from having to be locked in to one particular cloud vendor or another. The advantage, though, of that is because it is abstracted away from you, you could potentially more easily deploy that onto multiple cloud vendors than you could if you had a completely custom, closer to the metal solution. So, just something to consider. And one of my other favorites, I moonlight as a prod support for the application that I'm on. It's really hard to do production support on an application, as pretty much anyone can attest. There's just so many things that can go wrong. It's nearly impossible to have all of the information that you need to be able to triage things, to understand what a user was doing, and to then work backwards and figure out what are you going to do differently. When you're on-prem, when you're in a cloud environment, how do you give your production support team a single pane of glass so that no matter which cloud a particular user was on when they were on that particular part of your application, how do they get those logs? How do they ingest those logs? How do they understand those logs? Do they have permission to all the clouds? Have you actually tested that they have permission to all the clouds? Can they pull these things down? These are all things that you don't really think about until you've actually had to work a ticket and then realize that it takes 7 or 8 or 9 different people to give that one person the permission they need to be able to investigate what went wrong in the application. The other thing I moonlight on is security. When you're on-prem, there are things that you can just take for granted. You can take for granted the fact that someone is not going to be able to go up to whatever VM your application is running on and put in a USB drive. It won't happen. They have security perimeters in place. So because of that, you could put files on the disk that maybe aren't encrypted, that have passwords in it, but it's going to be safe. You can be sure that there's going to be no weird internet connectivity issues to where anything that your application's doing, it can't reach out to the public internet. And likewise, the public internet cannot reach into it. When you go to the cloud, it's a little bit different. You have to be the thing that enforces it. You have to understand what are the safeguards that are in place. And now that you're talking about a multi-cloud setup, if you have a service running on AWS that needs to call another service that's running on Azure, how do you know that you've properly secured the network traffic between them? Or in terms of how you even make that call, you have to think about authorization and authentication. Where are you putting those connection strings? How are you putting those in a way that won't accidentally leak out to the public? Cloud vendors, they all have their own interpretation of how you do identity access management. Some, like Microsoft Azure, they're really good at doing managed identities to where you don't have usernames and passwords floating around anywhere. There's no keys or anything involved. It's merely the fact that you have a service that's identifying itself and you're calling another service. You've already set up that authorization saying, hey, this can call that. Perfectly fine. When you're on GCP, they do have service accounts, but they provide the credentials in a JSON file, and you have to keep that JSON file safe. You know, kind of like what I talked about in my last presentation. You know, pretend it's your mother's JSON file. You know, you have to make sure that you keep her safe because you don't want that thing just kind of going around the internet doing what it will. How do you manage all that stuff? So when you go to a multi-cloud setup, these are probably just some of the things that you're going to be thinking about. It's not an exhaustive list at all. And it will solve some of the problems. You know, if you're worried about having an application that is highly available, that is resilient to disaster, deploying it to multiple clouds, it definitely will give you that. It'll also give you different problems as well. Things that you just can't think of and can't really appreciate until you've gone and done it and designed for it, importantly. Would I recommend a multi-cloud setup to a legacy application? Probably not. I would really say if you're going to be moving something from on-prem up to the cloud, just keep it in one. You might want to add on features or things that are tangential to it, but I wouldn't ever do it sort of day one. If you're doing a new application, would I recommend it be multi-cloud? Maybe. It's really tough to say prima facie if that's a good idea or not. It depends a lot on what the application needs to do. If you have a team that is really, really skilled at Microsoft Azure already, and you tell them, hey, this new application needs to be on AWS, well, you know, they're not going to be super happy with you. They've already learned a tool, they like a tool. People can, you know, we're kind of stuck in our ways at certain points in our lives. You know, I have a few gray hairs, so I understand what it's like to be sort of an old dog. You know, I don't want to be taught new tricks. But it's also part of software development. So why are you moving? Why are we saying that we have to go to AWS? What are the things that it does better than what we're doing right now? And can, you know, maybe 90% of the application live on one cloud, and the 10%, maybe the pub sub on GCP is better than anything else that I could possibly get on either Azure or AWS. Could I just put that part on the other cloud? Like, you could, but then there's a security perimeter that needs to be set up. You know, we as application developers, we have some knowledge of what goes on at an enterprise level, but it's definitely not our forte. There are people that are sitting there that are thinking about network traffic, that are thinking about identity access management, all the things that we build our applications on top of. Once you tell them that they have to deploy something to another cloud too, you know, they are going to be less happy than you are. It's an organizational, it's a mindset shift for how you have an application living on multiple clouds at once. So if it is something that you are considering, I would strongly recommend getting maybe a first, a second, and a third opinion. And that's, you know, if you're curious, you can email us at asktheteam@keyholesoftware.com. Just kind of get unbiased, egalitarian advice on what we would recommend. Because there are a lot of things that can go right with it. There are a lot of things that can go wrong with it. And if you don't plan for it from the outset, your chances of success just go down with the less and less amount of planning you do. So I hope you take whatever, if this is something you are actively considering, I hope you take the School of Hard Knocks advice that I have given, because these are things that I had not considered until I had to consider them, and apply it to you. And if you want to know more, if you want to see some of the different offerings we have, you know, feel free to drop us a line. But I hope that this at least has not scared anyone away from doing a multi-cloud setup, but instead is really giving you different things to think about and different things that you might not have considered otherwise. So if anyone does have anything they want to know about it, drop us a line, send an email to your favorite business development representative, and we'll talk. So it's not impossible to have a good multi-cloud setup. It's just difficult. That doesn't mean we shouldn't do it, and it can be really worthwhile. And I've already started doing it in terms of GCP. The stuff that I'm getting out of PubSub and BigQuery, I would have never been able to achieve on any other cloud vendor. And look for it in a blog post near you. So thank you all very much for your time. I hope you have a great rest of your day.